All right, so we're going to find the exact radian measure for 200 degrees. So this is a little proportion we set up, and we know that pi is 180, always, always, always. So we want to know what is 200. And then we can cross multiply. So 180x equals 200 pi. And then we're going to divide by 180, and then always reduce your fraction. So it does say exact, so that means you don't type this in on the calculator. You want to leave the pi in there. You can cancel the zeros. So now we have 20 over 18, which is 10 over 9. And that is the exact radian measure for 200 degrees. Now, the next one is sort of the same in the backwards direction. This is a radian measure, and we're going to change it into degrees. But we're going to use this same idea, because what do we know about pi radians? This is a radian measure right here. Pi radians are 180 degrees. Right? So if this weren't there, if it was just a plain pi, it'd be 180 degrees. Now it's divided by 3. So what's 180 divided by 3? 60. But there's 5 of those. So it's 300. Yep, 300 degrees. And you have a calculator. If you can't do that math without it, you're going to take 180, take a third of that, and multiply it by 5. And that's 300 degrees. Now, we definitely need a calculator for the next one. We're going to change 187 degrees, 19 minutes, and 46 seconds into a decimal. Okay? So we start out by typing in 187, and then we go into our angle menu. Remember, that's second apps, and we need the degree mark. And then we do 19, go back into second angle again, and choose the minute mark, which is the single hash. And then the tricky one. Do you remember where you get your seconds from? Where do you get your seconds? Alpha plus, right. And then when you press enter, it should say 187 point, I'm rounding off to the thousandth, so 329, 187.329. So the degrees and the minute marks, those come from second angle. So we type in our number first, and then the degree mark, or the minute mark, or the second mark, whatever it is we're looking for. Okay. Now we have an arc length problem. And we know the angle is 1.6, and the arc is 32.7, and we're going to find the radius. Who remembers the little formula that we use for arc length?
Radius over radians.
Radius times radians. So arc length equals radius times radians. So in this case, we know the arc length is 32.7. This is the arc length right here. So that's 32.7. We do not know the radius, but we know the radian measure of the angle is 1.6. So how will I solve that? Divide. Just divide. So I'm going to divide both sides by 1.6. So 32.7 divided by 1.6. And I'm rounding to the nearest thousandth. So it looks like R is going to be 20.5 438. Arc length equals radius times radians. Always. Radius times radians equals arc length. All right, now we want the angle measure for south-southwest. Okay, so this is where we get our compass. And we don't need to label everything in the compass. Let's set it up. And let's remember that north, south, east, and west. Right? Now, south, southwest. So I'm really interested in down here, right? So if I split right here, that would be southwest. And what would that angle be? Well, remember that north is 0, right? South is 180. This is 90, and this is 270. We have to remember that. That's the framework that we use. So when I do southwest, that's going to be 45 degrees past 180, so that's 225. Would you agree with that? I hope you don't memorize all those numbers. You got to memorize 0, 90, 180, 270. But it's going to get way wacky if you try to memorize everything. You just need to know that this is not, the quadrant is 90, and when you split it, that's going to be 45. Right? Now, I want south-southwest. So that means I have to split it again. And I'm either going to split it underneath or above. Which one is it going to be if I want south-southwest? Everybody's saying down, and that's right, because you're on the south side of southwest. So this is south-southwest. Now remember, this was 45. So when I split it, that is a 22 and a half. How did I get 22 and a half? Half of 45, right? It's half of 45. So now I want to know what angle is this. Remember, we always start from up here. This is 0. This is the beginning. So around we go. To here is 180, and I'm going an extra 22 and a half. So 202.5 would be the answer. 202.5 is the answer for that one. And then finally, we're going to draw a course of 312 degrees. So it's kind of using the same idea of the compass. If we're drawing 312, remember we got to start at 0. I'm going to start here. This would be 90. This would be 180. This would be 270. So I have to go even past that. So 312 would be sticking up here like this. Doesn't have to be perfect. Just get it up there in that quadrant. That's where 312 is. Because we start measuring up here. Okay? All right, that's your quiz tomorrow. So I put it in Schoology so you can print an extra copy if you want an extra copy, if you want to do it again. And really, guys, you need to, if we do something in class that you're not sure of, you need to take advantage of these office hours. Whether we have a quiz or not, that's irrelevant. Waiting till quiz day is not productive. You need to stay on top of it as we go. All right, let's get our notes out and your pink sheet. Today we're going to need your pink sheet. So we need our notes and our pink sheet. All right, so here we go. paper somewhere, maybe on the side, I don't know, I didn't really leave a spot for it, but somewhere, I want you to write, it's on the pink sheet, but I want you to write it anyway. I want you to write Sohcahtoa. How many of you have heard of or used Sohcahtoa before? Good. Most of you. That's super. We kind of jokingly say he's chief of the trigonometry tribe, but this is the mnemonic device that will help you with all right triangle trigonometry. So every time you see a right triangle, you should think Sohcahtoa. Here's what it means. The big three trigonometric functions are sine, cosine, and tangent.
This fourth?
Yes.
I can't find them.
Can't find what?
The notes. I got this though.
Okay, well, I handed the notes out at the same time I handed out the homework. It was a long time ago.
I got the homework too. I don't know what I do with the notes.
Okay, well, the notes and the homework are handed out the same day. So you'll just have to deal with it. We'll figure it out later. Those were handed out. We used them yesterday. So I don't know what the deal is here. So sine, cosine, and tangent. Okay? Now, the O stands for opposite. So every time you see an O, it's opposite. The A stands for adjacent. So every time you see an A, it's adjacent. And the H stands for hypotenuse. Now let's look at the first problem. It's a right triangle. 2, 3, root 13. And the angle is here. Remember, theta is your Greek variable that represents an angle. Now, with regard to this angle, this is the opposite side. The location of the opposite side depends on which angle you're looking at. Opposite means across from. Notice these two, the 3 and the 13, they touch the angle. This one doesn't. The opposite side is the one that doesn't touch the angle. It's the one that's across from the angle. The adjacent side is the one next to the angle, adjacent to. And of course, you all know what the hypotenuse is. That one's not questionable. The hypotenuse is the slanted side, the one that's across from the 90. Now, with that set up, my job is to find sine, cosine, and tangent. I'll start with those three. Sine, cosine, and tangent. By the way, I know that looks like sin, but in math class, don't say sin theta because that makes you sound goofy. It's sine theta. Okay, that's sine, cosine, and tangent. Now, according to your pink sheet and according to Sohcahtoa, sine is opposite over hypotenuse. These are fractions. So it's opposite over hypotenuse. So I look at my picture. The opposite side is 2. And the hypotenuse is root 13. So the opposite side over the hypotenuse. Now, I'm really not supposed to have a radical in the bottom. So do you remember what to do when you have a radical in the bottom? Multiply by it. So I'm going to multiply by root 13. And I'm going to get 2 root 13 over 13. Remember doing that a lot last year in freshman year? Now what about cosine? Well, Sohcahtoa. Cosine is adjacent over hypotenuse, right? And adjacent is 3. So we have 3 over root 13. Well, once again, we've got a radical down there. So we'll multiply by root 13. So we have 3 root 13 over 13. And then tangent, remember these are all fractions. Tangent is opposite over adjacent. So opposite over adjacent for this picture would simply be 2 over 3. Are you with me so far?
Not really.
Now, there are 3 more functions. When we say functions, the trigonometric functions, sine, cosine, and tangent are like the main 3, but then there are, I don't need the picture anymore, then there are 3 more that are the reciprocals of these. Now on the paper they're written on that side, but I'm out of room, so I'm going to write them over here. We have the cosecant. CSC stands for cosecant. All this is on your pink sheet. Cosecant. We have the secant, and we have the cotangent. These are simply the reciprocals of these. So the cosecant is the reciprocal of the sine. So remember when we said the sine was 2 over root 13? The cosecant will be root 13 over 2. And the secant is the reciprocal of the cosine. So remember we said it was 3 over root 13? So that's root 13 over 3. And the cotangent is the reciprocal of the tangent. So it is 3/2. When we start memorizing this, and we need to do that pink sheet stuff, the pairs, the reciprocal pairs, only one of them has a co in the word. So we have sine, cosecant, cosine, secant, tan, cotangent. See what I'm saying? I'm trying to help you keep these straight. When you say what's the reciprocal of the sine, it's the cosecant. Each pair has one cofunction in it. Princess?
Why for like the cosecant and the others, why can we have a radical, like just like a normal radical as opposed to the other one where it's like 2 root 13?
Okay, in the sine, the radical is in the denominator. Can't have a radical in the denominator. That's the problem. The radical itself isn't the problem, it's the location of it. So in the sine, when we did opposite over hypotenuse, that radical was in the bottom. But when I flip it and do the reciprocal, it's now on the top. And being on the top is fine.
Is the other side always going to be opposite of each other? Like it's always going to be flipped?
These are the reciprocals of these. So as soon as I know what the sine is, I automatically know what the cosecant is.
Okay.
These are the reciprocal functions. They are the reciprocals of these. So Sohcahtoa tells us these, and then we just make the reciprocals.
So we want to look at like the original and not like the 2 root 13 over 13?
Well, because if you flip this, look at what you have in the bottom.
Yeah.
Right? So it's better to flip this because then you don't have a radical in the bottom. It doesn't matter. You can simplify that. It's just an extra step that you don't need to do. All right, let's try the next one. B. We're going to do exactly the same thing. So the first thing I want you to do when you look at the picture is label right on the picture what is opposite and what is adjacent. We know that the angle is up here this time. Right? So which side is opposite? 5. This is your opposite side. This is your hypotenuse. and this is your adjacent side. So you now, using your Sohcahtoa or your pink sheet, you should be able to figure out what the sine and the cosine and the tangent are. Sohcahtoa. Sohcahtoa. Sine, cosine, tangent. All right, so what's our sine? 5/13. Remember, they're all fractions. So it's opposite over hypotenuse. They're all fractions. And all 6 of them are going to be fractions. What's cosine? 12/13. And then tangent will be 5/12. Perfect. Now, and no radicals this time to worry about. So now that we've done that one, now we can do the reciprocals. Remember, sine, cosecant. Cosine, secant. Tan, cotan. These are just the reciprocals of these. So this is 13/5, 13/12, and 12/5. Done. Easy. Easy, easy, easy. Uh-oh, look at the next one. Look at C. What? What'd you say? We're missing something. Not good. In order to fill in these, don't we need to know all 3 sides? Don't we use all 3 sides in our answers? Shoot. How are we going to figure out that 3rd side? We can't go on without it.
How do you find out? Isn't it like a squared, b squared equals c squared?
Exactly. What's that called? The Pythagorean Theorem. Absolutely, guys. You can't forget about all the stuff you learned before. If you know 2 sides of a right triangle, you can always find the 3rd side using the Pythagorean Theorem. And the Pythagorean Theorem says, like Jaden said, a squared plus b squared equals c squared. And c is the hypotenuse, always. A and b, no one cares. But c has to be the hypotenuse. So, isn't the hypotenuse what I don't know?
Yeah.
So I'll do 1 squared plus 3 squared. Oh, got ahead of myself. 1 plus 9.
Okay.
So x squared equals 10. So what is my hypotenuse? No. I got to square root both sides. So it'll be the square root of 10, which is just the square root of 10. So if I'm missing a side, which is going to be the case a lot of the time, I have to do the Pythagorean Theorem to find that missing side. Now, before I start doing my fractions, let's label opposite and adjacent. I know this is the hypotenuse, the root 10 that I just found. I know that's the hypotenuse. Now pay attention, my angle's up here. So which side is opposite? 3. And this one then is adjacent. So Sohcahtoa, they're all fractions. So opposite over hypotenuse, are you starting with 3 over root 10?
No.
Well, that's what we start with, but now we're going to rationalize it. So 3 root 10 over 10, because you're multiplying the top and the bottom by another root 10. What about cosine? Are we going to have to do the same thing?
Yeah.
Cosine is 1 over root 10. And then we'll multiply by our root 10s, and that's root 10 over 10. And then tangent is 3 over 1, or you could just write that as 3. So then how do I do the other three? What's the deal with the other three? They're just the reciprocals, right? So I'm going to flip my first step here, like Kennedy was talking about. That's going to be root 10 over 3. Root 10 over 1, which is fine, or you can just write that plain root 10. And then 1/3. Lindsay?
I'm a little confused on how you get what you got for sine. You got why would you multiply it by?
Okay, because it's opposite over hypotenuse is 3 over root 10. You are not allowed to have a radical in the denominator. So we multiply it by root 10, because root 10 times root 10 now is a plain 10. No more radical in the bottom. So we have 3 root 10 over 10.
Okay.
All right, one more in this section. Same situation, we're missing something. So we're going to have to do our Pythagorean Theorem. We're missing not the hypotenuse this time. We're missing one of the legs, right? So when you set that up, remember a squared plus b squared equals c squared. C squared is always the hypotenuse. So this is going to equal 25. 5 squared. Right? Now, the two sides are 2 and x. So I'm just going to say 4 plus x squared. It's 2 squared plus x squared has to add up to 25. 5 squared.
Wait, did you just pick which ones you want to put?
Doesn't matter. A and B do not matter.
Okay.
The only thing that matters is C has to be the hypotenuse. The other two legs, irrelevant.
Subtract 4.
Now we're going to subtract 4. So x squared equals 21. And then we'll square root. So that missing side is the square root of 21. Now we'll do exactly what we've been doing. We're going to make fractions for each of these functions. Before we do, let's label opposite, adjacent, and hypotenuse. This is clearly hypotenuse. Which side's opposite?
Square
Square root of 21. Yep, the radical side is opposite. This side's adjacent. Good. So now we're ready to go. Opposite over hypotenuse. Root 21 over 5. Adjacent over hypotenuse. I'm doing cosine. Adjacent over hypotenuse. 2 over 5. And opposite over adjacent for the tangent.
Square root over 2.
Okay, and remember, radicals on top are fine. So those answers are perfect. Now I got to turn them over. So reciprocal of sine is cosecant. CSC, cosecant. So that's going to be 5 over root 21.
Don't you have to multiply it?
And this one needs to be rationalized. We call this rationalizing. So 5 root 21 over 21 is my final answer for the cosecant. The secant isn't going to be a problem. The secant is just going to be 5/2. And then the cotangent is going to be a problem because it's 2 over root 21. Which I'll have to multiply. So 2 root 21 over 21. Okay, so there's lots to remember and keep straight, but it's easy. It's easy stuff. There's just a lot to keep track of. Now, if you look at the next problem, it is very similar. but it's set up a little bit differently. We're still gonna find our sine, cosine, tangent, and all that. The difference is, there sets the triangle, but nothing's labeled, and the only thing you know is that the sine is 2/3. Now wait a minute. I didn't label it, I'm telling you, theta is always the angle of the origin. When you have a setup like this, theta is always at the origin. Okay, so there's my triangle, and this is all I know. What am I going to do here, people?
Plug it in
What do you mean plug it in?
to the opposite and.
Oh, so I know that sine is the fraction opposite over hypotenuse. So if I look at this picture, the opposite side would be this one, would you agree? And the hypotenuse is of course that. So wait a minute, now it looks like the problem I just did. I have two sides, and I need to find the third one. Daryl? Yep, I'm gonna do the Pythagorean Theorem to find this missing side. Now remember, when you do your Pythagorean Theorem, we don't care about A and B, but C has to be the hypotenuse. So this is gonna equal 9. So we have x squared plus 4, x squared plus 2 squared. So x squared equals 5, and it looks like that missing side is the square root of 5. That look okay to everybody? All right, well, I already knew the sine already. What's my cosine going to be then? Root 5 over what? 3, yeah. Remember, this is adjacent, opposite, hypotenuse. Go ahead and label those if it helps you, for sure. And then what's the tangent?
2 root 5 over 5.
Okay, you're ahead of me. It's 2 over root 5. But when we rationalize that, because you can't have a radical in the bottom. This one's fine, it's on top. Can't have it on the bottom. It's going to be 2 root 5 over 5, exactly what she said. Now, these are the reciprocals. So if the sine was 2/3, the cosecant is 3/2. If the cosine was root 5 over 3, the secant is 3 over root 5, which will rationalize. Multiply top and bottom by root 5, get 3 root 5 over 5. And then the cotangent, I'm going to flip it here, will be root 5 over 2. Well, that wasn't so bad, was it? Well, we got another one. Just exactly the same. So we got our same picture. This time, all we know is that the cotangent is 1/4. Doesn't that make the tangent 4 over 1 or 4? Absolutely, because these are reciprocals of each other. And tangent is opposite over adjacent, Toa. So opposite over adjacent is 4 over 1. So here's theta. This is opposite, right? So that's a 4, and that's a 1. This is opposite. Remember, your angle is always at the origin. If you don't have an angle marked, it's at the origin. So this is adjacent, and this, of course, is hypotenuse, and the hypotenuse is missing. All right, do your Pythagorean theorem. Tell me what you get.
Radical 17.
Oh, you already got it done? Square root is 17. Because a squared plus b squared equals c squared. And that's how we got root 17. Is everybody okay with that? Remember, c squared is the hypotenuse. So it's always hypotenuse squared over here by itself. All right, fill in the ones, we already have the bottom 2 done. Go ahead and fill in the rest of those, and then let's check our answers. Are you awake back there? We have answers?
Yeah.
All right. What'd you get for the sine?
4, well, it's 4 under, yeah.
So you made it 4 root 17 over 17?
Yeah.
Yeah.
And this one then was root 17 over 4?
Yeah.
And then the cosine, you started this way.
Yep.
And ended up with root 17 over 17, and you can put a 1 there if you want, doesn't matter. 1 root 17 over 17. And then root 17 over 1, which is fine, or you can write it as plain root 17.
Yeah.
Okay? All right. Okay, now, it looks like the next one, it's exactly the same kind of problem. I didn't draw the triangle for you this time, so you're going to have to draw your own triangle. And also, the given this time, which is the cosine, already has a radical in it. So the cosine is root 5 over 3.
So the adjacent is root 5.
So the adjacent is root 5. And the hypotenuse is 3? Sohcahtoa. And remember, in this scenario, this is the opposite side over here, right? So that's why I put the root 5 there.
Is the opposite 2?
I don't know, I haven't figured it out yet.
Well, it'll be.
I need to do the Pythagorean theorem, right?
Yeah.
So that's going to be root 5 squared plus x squared equals 3 squared. A squared plus b squared equals c squared. What's root 5 squared? 5 plus x squared equals 9. Jaden said it was going to be 2, and he's exactly right. Doesn't x turn out to be 2? Because you get x squared equals 4, and when you square root, you get 2. Good work, Jaden. All right, so here we go. What's our sine? 2 over 3. And what's our tangent?
5 or 2.
2 over root 5 is the beginning, and then 2 root 5 over 5?
Yeah.
Don't rush through that. And then now our reciprocals. So cosecant will be 3 halves, that's easy. Secant will be 3 over root 5. or 3 root 5 over 5. And cotangent is root 5 over 2. All right, getting the hang of it? Do the last one on your own. Do problem D on your own. So you're going to want to draw your triangle and make sure that you're doing the Pythagorean Theorem correctly. What do you got? Before you get too far, look up here. Is this how you put your numbers originally into your triangle like that? Okay, that's good. That's good. Did you get 1 for your adjacent side?
Yeah.
Okay. Good. That's good.
I have a bathroom after I go. Can I give you the answer thing on the bathroom?
Yes, I know.
What? I was gonna give you the answers first.
Okay.
Well, for the cosine, it's root 17 over 17. Then the tangent's 4. Then the CSC or cos, whatever that is.
Cosecant.
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 Well, they gave us that. And then the secant is root 17 over 1. And then the cotangent is 1 over 4.
I think he's right. Anybody have a question about one of those? Remember when you get something over 1, like 4 over 1, you can leave it that way, or you can make that just a plain 4. Okay? All right. Now we are doing a different kind of problem. Okay, so you got your pink sheet out, because there's something on the pink sheet that we haven't even touched on yet. And that is those special right triangles from geometries. If you look at your pink sheet, you see in the middle of the page there, down the second half of the page, the special right triangles. You remember spending a lot of time with Mrs. Hollis or whoever you had, talking about 30, 60, 90 triangles and 45, 45, 90 triangles. You absolutely have to know that in a 30, 60, 90, the sides are in the ratio. Across from the 30 is 1, the hypotenuse is 2, and across from the 60 is root 3. You have to know that. That's got to be memorized. So I know you memorized it back then, but you may have forgotten it now. That has to be memorized. Across from the 30, no matter where the 30 is, across from the 30 is the 1. Always. In a 45, 45, 90, the sides are 1, 1, root 2. Because the angles match, the sides match. So the legs are both 1 and the hypotenuse is root 2. We have to know those ratios, okay? So for the time being, you got your pink sheet to help you, but eventually that has to be memorized. Now, what does that have to do with this first problem, which is find the sine of pi over 6. Well, the first thing I want you to do, thinking about tomorrow's quiz, pi over 6 is 180 divided by 6. And what's 180 divided by 6? 30. So we're really finding the sine of 30 degrees. Well, wait a minute. 30 degrees, that's one of our specials, right? So we're going to draw the same picture we drew a minute ago with those other problems, only now, instead of theta, that's 30. I know that angle now. I'm doing 30. So it goes at the origin. So this is the same triangle you drew for the last few problems. It had a theta there before. Now it's specifically a 30 because that's the angle in the problem. Now, I know as soon as I put the 30 there, I know this is 1 because across from the 30 is 1. My hypotenuse is 2 and the other side is root 3. If that's 90 and that's 30, this would have to be 60, right? I don't care about that angle, so I'm not going to label it. But across from the 30 is going to go 1. Now wait a minute. All the sides are labeled. I want the sine. I erased it, but Sohcahtoa, sine is what? Opposite over hypotenuse. So opposite over hypotenuse, the answer to this question is 1/2, 1 over 2. So you just found the sine of 30 degrees without a calculator. Wow, let's look at the next one. Tangent pi over 4. All right, so first of all, pi over 4. How many degrees is that? Pi over 4 radians. 45. We got 45, kids, by remembering that pi is 180. Right? Pi is 180. So 180 divided by 4, you have a calculator. You can divide it if you don't know what that is. Now, let's draw our picture. Same picture every time. My angle here is 45. So I'm drawing a right triangle, and the angle at the origin this time is 45. So what do I know about the sides? This is a 45, 45, 90. So the sides are 1, 1, root 2, right? Hypotenuse is root 2. Now I want the tangent. Toa, Sohcahtoa. Tangent is opposite over adjacent, which is 1 over 1, 1 over 1. This is opposite, this is adjacent. And that's it. Wow, this is easy stuff. Let's try the next one. Secant pi over 3. Guys,
Can we go back to the old class periods? These two are on.
Best math teacher ever, just saying.
they're not thinking so right now.
Oh, it takes
Mrs.
about
Casper.
38 years, Mrs. Ford.
All right, secant, I taught her that back in the day. Secant pi over 3. All right, here we go. Secant pi over 3.
You've been teaching for a minute.
180 divided by 3 is 60. So I'm finding the secant of 60 degrees. So I draw the same picture I always draw. Right there it is. That's a 60 this time. Now, if that's a 60, would you agree this is a 30 up here?
Yeah.
And across from the 30 is always 1. I just remember that, always. Across from the 30 is 1. So that's 1, the hypotenuse is 2, and across from the 60 is root 3. So this is my opposite, my adjacent, and my hypotenuse. Sohcahtoa. This is secant. Which one is secant but paired with? Secant's paired with cosine. So cosine is adjacent over hypotenuse. So secant will be hypotenuse over adjacent. Does that make sense to you? Hypotenuse over adjacent, it's reciprocal. So for us, hypotenuse over adjacent will be 2 over 1 or 2. We're going to do one more problem before your head explodes. We're going to do the cotangent of pi over 6. All right, what's pi over 6? How many degrees? 30. 30. Pi divided by 6, so they got 30. We'll draw the same triangle we always draw, and we'll put a 30 right there at the origin. Across from the 30 is 1. Hypotenuse is 2, other side is root 3. Cotangent. That's the reciprocal of the tangent. So tangent is toa. Tangent is opposite over adjacent. So cotangent will be adjacent over opposite. So adjacent over opposite will be root 3 over 1 or root 3. Now, that's good stuff. Easy stuff, but there's so much to remember.